Hi everyone. We are from Group 2 and will present on the topic of queue data structures, including both the standard queue and the priority queue. Let's start with understanding what a queue is.
A queue is a linear data structure that organizes elements in a specific order, following the FIFO or first in, first out principle. This means the first element added to the queue will be the first one to be removed, similar to a line of people waiting for service. The person at the front leaves first, and new arrivals join at the end. There are two ends in a queue, the front and the rear. When the queue is empty, both pointers are set to -1. Elements are added at the rear, which is called in queue, and removed from the front, called to queue. If the rear pointer reaches the maximum size, the queue is full. If the front pointer is null, the queue is empty.
Here are the basic operations of a queue. Enqueue, adding an item at the rear. Dequeue, removing an item from the front. Is empty, checking if the queue is empty. Is full, checking if the queue is full. Peek, viewing the front element without removing it.
Now, let's talk about the priority queue. Unlike a normal queue, a priority queue assigns a priority to each element. The element with the highest priority is processed first, regardless of when it was added. If multiple elements share the same priority, their order of arrival is used to decide who goes first. Some common methods used in priority queues include empty, to check if the queue is empty. Size, to get the number of elements. Push, value to insert an element and reorder by priority. Pop, to remove the highest priority element. Top, to view the highest priority element. Swap, to swap contents with another priority queue. Emplace, value to add a new element at the top by priority.
Finally, here is a comparison between a regular queue and a priority queue. A queue removes elements in the order they arrive, FIFO, while a priority queue removes elements based on priority. Priority queues consider the priority of elements, regular queues do not. Examples of queues include lines at a bus stop, while priority queues are used in hospital emergency rooms where patients with critical conditions are treated first.
Let's look at how a normal queue works in C++, using a simple hospital example. Inside the main function, we create a queue of strings called hospital queue. Queue, hospital queue. This queue will store the names of patients in the order they arrive. Now, we add 3 patients into the queue, one after another. Hospital queue.push, fever patient. Hospital queue.push, stomach ache patient. Hospital queue.push, accident patient. The first patient has a fever, the second has a stomach ache, and the third has been in an accident. Even though the accident is serious, in a normal queue we still follow the rule first come, first served. Next, we display the message, cout, normal queue, first come, first served. This lets the viewer know how patients are being treated in this queue. Then we use a while loop to go through the queue. So the output will be normal queue, first come, first served. Fever patient is being treated. Stomach ache patient is being treated. Accident patient is being treated. This shows how a normal queue works in real life. Whoever comes first gets treated first, no matter how serious their condition is. Next, we'll learn how a priority queue can change this order by treating the most urgent cases first. Inside the main function, we declare a priority queue. Priority query, vector, greater, priority hospital. This line may look a bit complex, but here's what it means. Each item in the queue is a pair, where the first value is an integer for priority, and the second is the patient's name. We use greater seed so that smaller numbers come first, meaning higher priority. Now we push 3 patients into the priority queue. Priority hospital push 2, fever patient. Priority hospital push 3, stomach ache patient. Priority hospital push 1, accident patient. Here, the accident patient has priority 1, the fever patient has priority 2, and the stomach ache patient has priority 3. Lower number means more urgent. Let's watch simulation of real-world application in hospital.
The first patient has just returned from vacation, feeling hot and weak with a fever. He registers at the reception and waits his turn. A second patient arrives, suffering from stomach pain. She registers her name and waits right next to the first patient. Suddenly, an ambulance arrives. The third patient is in serious condition from a road accident and is taken straight into the doctor's room. The fever patient came first, and the stomachache patient came before the accident patient, yet he is treated first. Hospitals follow a priority queue. Here, the most serious cases are treated first, regardless of when they arrived. Fever and stomachache patients will wait a bit longer for treatment. So now you understand the difference. A queue means waiting in order, but a priority queue ensures urgent cases are helped first.
In summary, a queue processes elements in the order they arrive, FIFO, like patients waiting at a hospital reception. A priority queue processes elements based on urgency, like an emergency room where critical patients are treated first. Our video simulation illustrates these concepts in action. Routine patients are seen in the order of their arrival, while emergency cases receive priority care. This highlights how queues ensure fairness, and priority queues save lives by addressing urgent needs first. That's all from us. Thank you for lending your ear. Hope you enjoy.